This talk is about FreedomBox, the home server appliance. My name is James Valleroy. I've contributed to the FreedomBox project for many years, and I'm also the release manager for the project.
Hi, I'm Sunil Mohan Adapa. I've been a core contributor to the FreedomBox project since 2013. Before that, I worked on independent consulting and contributed to various free software projects. I'm currently employed at ThoughtWorks, who are sponsoring my work on FreedomBox. Today, James and I would like to share with you all the exciting changes that we did in the FreedomBox project. But first, we'll give a quick introduction on what the FreedomBox project is. After that, we'd like to put everything into perspective and talk about how much progress we made against the goals of the FreedomBox project. Finally, we'll talk about how you as a contributor to the Debian can contribute to the FreedomBox project. And we'll have some time for questions and answers after that.
So what is FreedomBox? Well, it's a server that lives in your home, and it keeps all of your data private in your home. FreedomBox is for non-experts. This means you don't need any special technical skills to use it. It makes it easy to install an application with just one click. Everything from a wiki to a chat server. And it doesn't require a lot of time and energy to keep it running. All of the FreedomBox software is a part of Debian. It's packaged and maintained in Debian. And we don't use any external repository. FreedomBox runs on a lot of different hardware, including cheap and low power boards. And we expect people can use these in their homes and keep them running all the time. And today, FreedomBox is an appliance. This means you can purchase it online and have it delivered to you.
Last year has been a great year for FreedomBox, not just in terms of the software changes we have implemented, but also we took a great leap in popularity and user participation. And the biggest change that happened to the project over the past year is the launch of the home server kit. We announced this in DebConf last year, but it has been a great success since then. We essentially teamed up with Olimex, who are open source hardware manufacturer based out of Bulgaria. They sell a single board computer called Lime 2. And this single board computer is what went into the FreedomBox home server kit. Essentially a metal casing, an SD card loaded with FreedomBox, then a battery pack and power supply put together, turned it into an appliance that users can order online. So users do not have to worry about choosing the right hardware and setting it up themselves. They instead can order a hardware from the store and easily set it up as simple as a Wi-Fi router at home. And since the launch of the hardware kits, we have seen a significant increase in user participation. Olimex also seems happy about the launch as they have followed it up with a drop in price for the kits, as well as launching a new hardware attachment to host a SATA drive that can handle up to 2 terabytes hard drive. This hard drive can be used to store media and serve media on the network. They've also made the kits available to direct purchase for the users in the US. We've also added support for other hardware, 2 very low-cost boards from Pine64, one hardware board that has multiple Ethernet ports that can be used as a router, and one of the cheapest hardware boards out there yet capable, the Orange Pi Zero. We've also started building images with backports enabled, so that latest changes of FreedomBox can be made available, along with other changes such as matrix synapse being available for federating with all other matrix synapse instances out there. Recently, we started experimenting with a new approach for building our hardware images for ARM single board computers. That is to build a UEFI based generic image. Earlier, we were building an image for each of the single board computers, which is obviously not a scalable approach. But with this new approach, we're really hopeful that all of our future hardware can be supported with very little effort from our project. Essentially, any Debian kernel, any single board computer with support from Debian kernel will be supported by FreedomBox as well automatically. This is an approach first used by OpenSUSE project, I believe, but others probably are also using it. The idea is to use an external UEFI based firmware such as U-boot, and keep the operating system image separate, and that image in our case is FreedomBox, and depending upon how the firmware is procured, we can support various boards without having to change the operating system image. With this approach, we have already tested a newer version of the Lime 2 board, two very powerful boards from Pine64, and also the latest Raspberry Pi 4. The one advantage with this approach is that these images are fully free in the sense that they do not contain proprietary firmware from Raspberry Pi. And so we are now thinking about treating Raspberry Pis as similar to how we treat AMD and other Intel hardware, where the firmware is proprietary and typically the OS is completely free software. On the software side, we are now focusing on new use cases. Network attached storage is not a primary goal of the FreedomBox project, but since Debian can do a lot already, we thought that with very little effort we can provide capabilities to take backups of all your devices at home, also host some of the media that you have on FreedomBox, and then stream it to appliances like televisions, and also share large files using FreedomBox. So we've made a lot of changes in this area, and we will soon be making announcements about our NAS capabilities. With the rise of online video calling, we started to provide those features in FreedomBox as well. The first one being integrating the CoTurn app in FreedomBox to provide a turn as well as turn server. We've tested this successfully with Matrix Synapse and Reachability. People can now make end-to-end video audio calls using these two services.
This year, we also focused on improving the security of FreedomBox. One way we did this is through systemd sandboxing features, which can be enabled for each service, and it limits the capabilities of what that service can do. For example, prevent it from changing users on the system, or have it use a private temp folder. We've only enabled this for a few services so far, so we still have a long ways to go. And we will contribute patches to those packages so they can do the same. Another item is that we have enabled strict content security policy. This prevents certain types of attacks in the user's browser. And client-side sandboxing. This is for any JavaScript which is served by the FreedomBox to limit what it can do in the browser. This year we also incorporated need restart into FreedomBox. This will check whenever a package is upgraded if its files are being used by some service, and then restart that service to ensure that it has the latest security fixes. And also, when a kernel is upgraded, we will schedule a system restart so that you can be sure that you are using the latest kernel. We've also improved our update mechanisms. We have a manual update button, and we ensure that the apt cache is up to date when it's run. We also fixed an issue where the FreedomBox interface being upgraded would interrupt the upgrade process itself. And we've enabled an apt option so it can automatically recover from certain errors. Some more new apps were added to FreedomBox this year, including Wireguard VPN. This is a higher performance VPN, and it also fits into our reachability goals. Wireguard is available in backports, but for FreedomBox to configure it, it needs a newer version of Network Manager. So for FreedomBox, it can only be used through testing, but it will be part of our Bullseye release. GitWeb is an app that allows you to create or clone a Git repository, push commits to that repository, and then have it displayed in a web interface. And Performance is an app that adds several system monitoring services, and these can be viewed through dashboards in Cockpit. I want to mention both GitWeb and Performance were not on our roadmap for this year, but they were just contributed by members of the community. We also had a number of updates to the user interface. For example, we show the logo for each application on its page. We also flattened the app pages by removing the tabs and replacing them with action buttons that are shown in a toolbar. To enable or disable the applications, we now have a toggle switch which replaces the checkbox that we had before. And also, when you click a button, it will show a spinner animation so that you know something is happening. Altogether, this I think gives a much more fresh and modern look to FreedomBox, and that is something that users expect, especially if they're most familiar with a mobile phone interface. Some other changes that happened this year. FreedomBox is in Buster backports, and we have updates usually every 2 weeks. And this is what we recommend for the vast majority of FreedomBox users, to be unstable and to have the backports. We added a container for development and test. This is based on the systemd container features, and it is an alternative to the virtual machine that we had before. Our manual has been translated to Spanish, and it's available in the FreedomBox doc ES package. If you switch FreedomBox to Spanish and you click on the manual page, you'll be shown the Spanish page if it is available. We've added more components to our component-based API to cover diagnostic tests, user groups, notifications. These are components that any application on FreedomBox can take advantage of. For example, we're using notifications to warn the user if there's low disk space. We are also renaming the package from Plinth to FreedomBox. This is the main package used in FreedomBox. And we've already renamed the binary package. The source rename is still in progress, and that's currently in the new queue. A couple of new languages were added to the interface, Serbian and Arabic, and we saw a lot of activity in our translations overall. We also launched a new discussion forum, which is at discuss.freedombox.org. This is an instance of Discourse, and what we found is that we have a lot more interaction with our users through this forum. So for example, periodically users will show up and will report an issue or request a new feature or just give us feedback about the project. And we never saw this before when we just had the mailing list and the IRC channel. So I think this has really improved our interactions with the users. We also made a number of changes and a complete redesign of our website at freedombox.org. This kind of helps all the information flow together. You can scroll from one section to the next. And we have a separate page for each hardware device that is supported. Besides that, to support our growing community, we've added a code of conduct and also the community governance page. This covers how decisions are made in the project. And we also have translations of the website. Currently, Czech and Spanish are the most complete, so those are enabled on the live site right now. And we have a couple more languages which are on the way. So some statistics for last year. We had approximately one release every 2 weeks. A couple more releases were to handle unexpected issues. A total of 66 contributors to the Git repository, and 13 of those were regular contributors who made multiple commits. We had a total of 50 people contributing to translations, and so we have 5 languages that are nearly complete for the interface, 6 more languages that are over 70% translated.
So we had a great year for FreedomBox with all of the progress, and also in the previous years. So how does this all stand against the overall objectives of the project? After all, the FreedomBox project is very ambitious. We want to provide a suitable replacement for all of the online services that people are using out there. So where do we stand in terms of what we have done so far? We have a very respectable set of 25 or so applications that can do a whole bunch of things for users. We have Tor and I2P to handle anonymity networks. We have Matrix and Reachability to do instant messaging. We can host a wiki or a blog on FreedomBox. Wireguard and OpenVPN can be used for turning a FreedomBox into a VPN server or a VPN client. We further can download torrents, read news, perform collaborative editing, perform file synchronization across multiple devices in an encrypted way, have an anonymity enhancing proxy server, and also do audio conferencing at a large scale. Now, what is glaringly missing from all of these are 3 often asked for applications, which are Nextcloud, then social networking, especially using ActivityPub applications such as Mastodon or PeerTube, and also an email server. If we look at various use cases satisfied by FreedomBox, for anonymity and privacy, we have some reasonable set of applications, but we still need a lot more focus in that area. In terms of self-hosting, we're very strong with so many applications available, but some of the important applications that I've already talked about are missing. We started focusing on the NAS area, and we're almost already there because most of the software is already available in Debian. We also, because we are using Network Manager and some of its capabilities, we've also been able to add features needed for a Wi-Fi router, but we still need a long way to go in that area before a FreedomBox can be set up as a Wi-Fi router as easily as a regular commercial Wi-Fi router. In case of video conferencing, we are able to do audio-video calls with Matrix and Reachability, but 2 of the very popular conferencing solutions such as Jitsi and Big Blue Button are missing from this. We would definitely love to see these in Debian so that FreedomBox can add support for them. Another big area for FreedomBox is the reachability, an area we call reachability. The essential problem being how do you host a server at home and make it behave as if it's sitting somewhere on a hosting provider's setup. Some people do not have a static address. Some people do not even have a public IP address. In such cases, how do you host servers at home? In this area, what we don't have is a solution that works in all cases in a perfect manner. We have smaller solutions that work in certain cases. For example, dynamic DNS can work when the user has a public IP address, but it keeps on changing. One area of hope is that IPv6 becoming more and more popular each year. In future, we might have IPv6 addresses for all home servers so that they can be set up as nicely as a hosting provider setup. We also need to set up MX records and DKIM records and so many other things via DNS server. We need solid TLS certificates. A lot of these solutions we already have in FreedomBox, but a recent analysis of how we're doing in that area revealed that we need a lot better user experience, trying to hint users of what solutions they should be approaching, trying to automate a lot of those steps, reducing the technical burden on the users, and so on. So we now have a plan for improving the user experience for users in this area, suggesting to them what solutions they should be using. In terms of hardware support, we don't believe that going through the Debian installer steps and then doing an apt-get install FreedomBox is the easiest way for users to set up home servers. So what we've been doing is producing images for various single board computers that they can directly put onto an SD card and plug in the SD card to get things done. So we already have support for 20 plus single board computers. And because of the recent progress we've done with generic images, we hope that a lot more boards will be supported in the future. And without a lot of effort for the project itself. Talking about some of the core areas where hosting servers are supposed to be strong, we now have we started doing at least application sandboxing using systemd. We already have automatic upgrades using unattended upgrades. We also have a solution in FreedomBox now for dealing with changes to configuration files that prevent automatic updates from happening. Now, this solution is not a great solution in terms of it being a little bit hacky, but this solution currently works very well for situations where user does not have to care about editing configuration files or answering questions about three-way mergers and so on. So we are able to upgrade all of the packages in FreedomBox without ever asking a question to the user. We also handle automatic restarts using need restart. We handle firewall automatically, obtain TLS certificates automatically using Let's Encrypt. But what we are lacking in this area is better sandboxing, especially when compared to some of the other projects out there using containers for hosting applications. Another area is infrastructure. We're taking backups of all of the application data in a nice manner. We've implemented a robust solution there. Then we're also taking automatic disk snapshots using Btrfs file system and the Snapper tool. We have very decent networking provided by Network Manager, even for some of the advanced networking cases. FreedomBox in general provides a very simplified user interface, and it does not want to implement advanced system administration. For those cases where users might want to do advanced system administration, we are referring them to the Cockpit application. Cockpit is now a required dependency of FreedomBox, and users who have to do advanced management like setting up RAID disks and VLANs and so on, they can always jump to the Cockpit application and do advanced operations there. We also have a decent solution for single sign-ons, but that can be improved quite a bit further. We also want FreedomBox to turn into a identity provider by providing OAuth and OpenID Connect based sign-ons for various other applications, but that is still ahead for us. We also have one important feature missing from backups, which is automating all the backups to take them regularly to a remote location. We already can take backups to a remote location. So that's where we are with infrastructure and on the overall status of the project. So I would say on the overall, we're in a pretty good shape, but we have a few significant missing blocks.
Let's discuss our plans for the coming year. There are a number of major features that we want to add or improve in FreedomBox. This includes the NAS and audio-video conferencing, which have already been discussed. We want to make sure that we can meet all of these use cases with FreedomBox. Also, we want to package Nextcloud in Debian and make it available through Debian Fast Track. We want to improve our reachability to work for users with all kinds of different network situations. We will implement an automatic upgrade to the next stable release, so users who are currently running Buster with backports will be automatically upgraded to Bullseye. We will package Charlie, which is a bookmarking application, which was in Debian before but got removed. Mail server is another feature that so many users have asked about. We have a detailed plan on how to implement it, so we just need to put the effort in and actually get it done. And finally, we would like to have a Fediverse application. This is for federated social networking based on the ActivityPub protocol. So some of the most popular applications out there are Mastodon and Pleroma, but we will also consider how it can be packaged and maintained in Debian and how it runs on our lower power devices. We're also improving our developer framework. We're moving towards declarative apps. This means that each application doesn't need to write a lot of Python functions and have a lot of boilerplate. Instead, the app will simply describe itself and what it needs and the components that it wants to use. We have some cleanups planned for the Bullseye release, including properly building all of the manual pages from the wiki source files. And we want to add functional tests to our CI pipeline, along with the unit tests and building the package. Functional tests will start a FreedomBox in a container and control a web browser, have it connect to the FreedomBox, and check that everything is working. For hardware, of course, we want to support many more boards, including 64-bit boards, and will be possible through our generic images. And we also want to have cheaper boards so that everyone can afford a FreedomBox.
There are other projects similar to FreedomBox that try to achieve similar goals. These projects, at least some of them, they take a different approach to installing applications. Instead of installing Debian packages for an app, they try to install containers. These containers come with the app as well as some of the libraries that many of the libraries that it requires. Now, there are two main advantages with taking such an approach. One, somebody trying to package an application for this particular software, they do not need to wait for the application to be packaged as a Debian package. Instead, they can write a small script and make sure that from the upstream, they grab all the application sources as well as libraries required and then put them inside a container. The second approach is sandboxing provided by the containers. Now, this approach has problems as well. It bypasses some of the main guarantees that Debian provides. For an application to that is working at home as a home server to contact a centralized server and report on the user would be a catastrophic failure in privacy. Also, we cannot have any binary blobs running in that application. When an application goes through the Debian's new queue or and gets sponsored by a Debian developer and ends up in the Debian main repository, we can reasonably assume that it will not phone home on the user when it is running. Also, it can be assumed that binary blobs will not be present inside that application. Security updates will be provided as part of stable updates and also testing. Most Debian packages also provide a reasonable upgrade mechanism, at least from one stable version to another stable version. And this is what FreedomBox does. So instead of installing from within the containers, FreedomBox always relies on Debian packages. So here's how you can help. In the self-hosting application category, there is a disproportionately large number of applications that have not been packaged for Debian yet. And this is also the reason why FreedomBox has fewer applications compared to some of the other solutions out there. So you can help by picking up a self-hosting application and packaging it for Debian. Now, making that available, any Debian package can be made available in FreedomBox with very little effort after that. Take a look at the list of self-hosting applications that we have compiled on the Debian wiki. As of special mention is the lack of Fediverse and ActivityPub related applications such as Mastodon and PeerTube missing from Debian. We would love to see those applications available in Debian. So another area we'd love to see is Debian installer. There is a lot of talk about providing an option in the Debian installer to allow blends to be installed during installation. And if a FreedomBox is installable in that way, it would bring a lot of exposure to all the Debian users out there regarding FreedomBox and other blends. We hope to be able to help out the developers working on this issue in the coming weeks or months, whatever our time permits. You can also help FreedomBox project by translating the FreedomBox interface, FreedomBox manual, freedombox.org website into your own language. Chances are, if you're a Debian developer, chances are you already helped out the FreedomBox project in a certain way, in one way or the other, because we depend on a lot of Debian core features. And for that, a heartfelt thank you from all of us at FreedomBox. We have plenty of time for Q&A or a few links to the FreedomBox project. Thank you very much.
Thank you very much for the fine talk, Sunil and James. So I saw in the IRC during the talk that many of us are interested to try it out if we were not using it already. So it's a great project. Thanks. So by way of questions, we see that many of them have already been answered. The questions that are on the pad. Let's just quickly check here. But for some reason, the pad on the stream doesn't seem to be behaving. Okay, while we try and fix that, let me just check if there are any questions on RC. Okay, it looks like on RC there are no unanswered questions. And in the pad, nearly everything has already been answered as far as I can see. Okay, so for the benefit of those who are just watching the stream and maybe not able to access the pad, since it has a couple of restrictions, we can just quickly cover some of the questions. So there was a question if there are any plans to integrate federated clients into FreedomBox, and the answer is yes, there are such plans, but the challenge is that some of the packages are not in the best shape currently in Debian, but there is work along that line. Okay, so there is a new question coming up, which is, has it been considered to implement a SIP server in FreedomBox? Perhaps Sunil
Yes.
or James?
Yes, we did consider a SIP server, but we did have Repro as a SIP server earlier, but Repro got removed from Debian a few months, maybe a year, more than a year back. And so we had to remove it from FreedomBox as well. But if there's a good implementation available, and if there is some interest, we would definitely like to add a SIP server back.
All right. Thank you very much. We hope that answers the question at the end of the page. I'm sorry I can't scroll the pad for some reason. Yeah. Okay, so someone is also asking, I use a containerized setup to deploy most of my services using Docker Compose containers, which are isolated and they are present behind a reverse proxy. Can a similar setup be achieved with FreedomBox on servers?
Yes, a lot of FreedomBox users have deployed FreedomBox and used FreedomBox to set up some of their applications. And some of the applications that were missing from FreedomBox, they deployed using containers. And FreedomBox then provides Let's Encrypt certificates and firewall and a few other things at the host level, then forwards the traffic to the container. That is certainly a possibility.
Right. Thank you very much. Okay, so someone else is asking a question. Is there a good self-hosting service available for FreedomBox to share Firefox bookmarks between devices and users?
James?
I assume the best option here would be the Firefox sync service to get that actually packaged into Debian. I'm not really sure how many requirements or dependencies it has. So other than that, possibly you could store your bookmarks in a file that's shared through SyncThing and use SyncThing to synchronize it between different devices, but that might not be as well integrated as Firefox Sync. I am going to work on packaging Charlie as well, but that's maybe something different than what you want. That's more of a web app that can store and share bookmarks.
All right, thank you. Can we just check if there's any other question that has come up? Okay. Okay, so in connection with the Raspberry Pi, you did answer that the image is fully free, but then in the answer you mentioned that the user might have to fetch firmware separately. So the follow-up question is, what would need the private blobs to work? In connection with the Raspberry Pi. I don't know if
you... So Raspberry Pi boot process requires a binary blob, for which no free software equivalent exists, as far as I understand. So this blob actually first runs on the GPU, and then starts the ARM processor, and then a few other things happen. Most of the Raspberry Pi images that are being shipped out there contain these proprietary blobs. And in FreedomBox project, we've been unhappy with it for a while. Now we are adopting a solution where the OS images themselves do not have to contain these proprietary blobs. What we're now recommending users is to obtain the firmware separately. There is a project called Pi Firmware Task Force, and this particular project forks the Tiano Core project and provides a UEFI firmware. It also comes shipped with the Raspberry Pi's boot blobs, the proprietary blobs. So all of that in one package, user can obtain and put it on an SD card, whereas the primary operating system, which is FreedomBox, can be put on a USB disk, and that way Raspberry Pi first boots the proprietary blobs, which then start the Tiano Core based UEFI firmware, which then starts a FreedomBox UEFI image. So when we are shipping Raspberry Pi images, this way we don't have to include proprietary blobs in the OS image itself. We can request users to obtain the firmware separately, even though it is a some parts of the firmware are proprietary. Hopefully, in future versions of Raspberry Pi, the SPI flash will be larger and would contain this sort of a firmware already, so that the OS images don't need to have proprietary blobs anymore. So at that point, it would be pretty much similar to AMD and Intel hardware, which have proprietary BIOSes, while the OS images are entirely free.
Okay, thank you very much, Sunil and James, for your work, and also, of course, for the entire FreedomBox project. There are a couple of other questions on the pad, but we no longer have time for those, so perhaps you'll be able to continue answering them there. But thank you very much for the talk and delivery.
We have a discussion forum. You can post your questions there as well. We will, of course, continue answering the questions here. We also have provided our email addresses if you want to reach us for any further questions.
Perfect. Thank you very much.